The electrical conductivity secret: is banana peel tea really feeding your plants? Have you ever made banana peel tea for your garden because someone online claimed it was a miracle fertilizer? Maybe you've soaked banana peels in a bucket of water, waited a few days, and then poured that homemade brew around your tomatoes, peppers, or roses, hoping for bigger blooms and better harvests. But here's the question very few gardeners ever ask: how do we know if banana peel tea is actually delivering nutrients to plants? Today on the Soil Science Garden, we're uncovering one of the most overlooked secrets in gardening science: electrical conductivity, also known as EC. And by the end of this video, you'll understand exactly how scientists and professional growers measure nutrient strength and what happens when homemade banana peel tea goes head-to-head against commercial fertilizers. Let's get started. When gardeners talk about fertilizers, we usually focus on nutrients like nitrogen, phosphorus, and potassium. But nutrients don't magically move from the soil into plant roots. They first need to be dissolved in water. Once dissolved, these nutrients become tiny charged particles called ions. And here's where things get interesting. The more ions present in water, the better that water can conduct electricity. That's exactly what an EC meter measures. Think of electrical conductivity as a nutrient detector. It doesn't tell you the exact nutrients present, but it does tell you how many dissolved particles are floating around in the solution. A low EC reading generally means fewer dissolved nutrients. A high EC reading usually means more nutrients available for plant uptake. Professional greenhouse growers use EC meters every day to monitor feeding programs and maximize crop production. Yet most home gardeners have never even heard of them. Now let's put banana peel tea to the test. Banana peel tea has become incredibly popular because it's free, easy to make, and uses kitchen waste that would otherwise be thrown away. Banana peels contain potassium and other nutrients. Soaking them in water should transfer those nutrients into the liquid. And if nutrients enter the water, plants should benefit from them. At least that's the theory. To find out what is really happening, imagine we set up a simple experiment. We prepare 3 containers. The first contains plain water. The second contains homemade banana peel tea that's been brewed for about a week. The third contains a commercial water-soluble fertilizer mixed exactly according to the manufacturer's instructions. Then we test all 3 solutions with an EC meter. The plain water gives us our baseline reading. The banana peel tea shows a higher reading, which tells us that some dissolved nutrients and organic compounds have entered the water. But then comes the surprise. The commercial fertilizer often produces an EC reading that is dramatically higher than the banana peel tea. Why? Because commercial fertilizers are specifically designed to dissolve quickly and completely into water. They're packed with readily available nutrients that plants can absorb almost immediately. Banana peel tea, on the other hand, only releases a portion of the nutrients trapped inside the peel. Most of those nutrients remain locked within the plant tissue. This is the first big lesson from our experiment. Just because a material contains nutrients doesn't mean those nutrients are immediately available to plants. That's a critical distinction many gardeners miss. In fact, nutrient content and nutrient availability are 2 completely different things. Banana peels absolutely contain valuable nutrients. But soaking them in water for a few days doesn't unlock all of them. And that's where things get even more fascinating. In part 2, we're going to explore why commercial fertilizers produce much higher conductivity readings, why high EC can actually become dangerous for plants, and what this experiment teaches us about using banana peel tea the right way in a soil-smart garden. Trust me, you don't want to miss it. In part 1, we discovered that banana peel tea does increase electrical conductivity compared to plain water, proving that some nutrients enter the solution. But we also found that commercial fertilizers typically produce much higher EC readings. So what does that actually mean for your plants? Let's dig deeper. One of the biggest reasons commercial fertilizers show higher conductivity is because they're designed for immediate nutrient delivery. Manufacturers formulate these products using highly soluble nutrient sources. The moment they're mixed with water, nutrients dissolve and become available for root uptake. That's why the EC meter responds so strongly. It's detecting a large concentration of dissolved ions. For crops with heavy nutrient demands, this can be extremely beneficial. Think about tomatoes, peppers, cucumbers, squash, and many fruiting plants. These crops require significant amounts of nutrients throughout the growing season. A properly applied commercial fertilizer can quickly provide what these plants need during periods of rapid growth. But here's where many gardeners make a mistake. They assume higher EC always means better results. It doesn't. In fact, excessively high EC can create serious problems. When too many dissolved salts accumulate around plant roots, water becomes harder for plants to absorb. Even when the soil appears moist, roots can experience stress. Gardeners may notice leaf burn, yellowing foliage, stunted growth, poor flowering, or reduced harvests. This is why professional growers monitor EC so carefully. They aren't just trying to maximize nutrient levels. They're trying to maintain the ideal balance. Too little nutrition limits growth. Too much nutrition creates stress. Now let's return to banana peel tea. One interesting thing about its relatively low EC reading is that it's generally very gentle. Because nutrient concentrations remain modest, the risk of fertilizer burn is minimal. This makes banana peel tea relatively safe for seedlings, herbs, ornamentals, and young plants. But there's another important lesson hidden inside this experiment. The conductivity meter measures dissolved nutrients, but it doesn't measure biology. And soil biology is where the real magic happens. Healthy soil contains billions of microorganisms. These microbes constantly break down organic matter and release nutrients in forms plants can use. This means banana peel tea may still provide benefits beyond what the EC reading alone reveals. It may contribute organic compounds that support microbial activity and improve nutrient cycling within the soil ecosystem. However, if your goal is maximizing nutrient extraction from banana peels, there's usually a better approach. Composting. When banana peels are added to a compost pile, microorganisms gradually decompose them and release nutrients over time. The resulting compost not only supplies nutrients but also improves soil structure, water retention, and microbial diversity. In many cases, composting banana peels captures far more of their long-term value than simply soaking them in water. So what's the ultimate takeaway from this experiment? Banana peel tea is not a miracle fertilizer. It's not a replacement for a complete fertility program. And it's unlikely to provide enough nutrients on its own for heavy feeding crops like tomatoes and peppers. Far from it. Banana peel tea can be a valuable supplemental amendment, a sustainable way to recycle kitchen waste, and one small piece of a broader soil building strategy. The smartest gardeners don't choose between natural methods and commercial fertilizers. They understand the strengths of both. They build healthy soil with compost, mulch, and organic matter. Understanding the science, making informed decisions, and growing healthier plants season after season. If you found this experiment helpful, subscribe to the Soil Science Garden for more practical gardening science, leave a comment with your experience using banana peel tea, and share this video with a fellow gardener. Let's keep growing smarter from the ground up.